this is the assignment for today. I know it looks like a massive packet or it looks like a review. Basically, it's just a review of what we've learned so far with quadratic functions, and it kind of introduces you to a couple new things that we're going to be getting to with quadratic functions. So this first page is fill in the blank. It's helping you to get more familiar with all of the terms associated with quadratic functions. Keep in mind this term right here, zeros, roots. What are zeros and roots the same as? Do you remember? They're the same as the x-intercepts. So at the bottom of this page, numbers 9 through 11, it says, determine whether the quadratic functions have 2 real roots, 1 real root, or no real roots. The number of roots, they're basically asking how many x-intercepts. So the first thing is asking you how many x-intercepts. So find the x-axis and look at, is that graph touching or crossing the x-axis once, twice, or none at all? So your answers for that first blank will be 1, 2, or 0. Then on the bottom line, it asks for the zeros. It's basically saying, okay, so what are they? So if there's one x-intercept, what is that x-intercept? What is the x value of that x-intercept? Okay. On the next page, there's one graph that's graphed for you, and they're asking you to identify the axis of symmetry, the vertex. Again, how many zeros? They're asking how many x-intercepts there are, and then what are those x-intercepts? What are the x values of the x-intercepts? Then it asks you to graph 2 of them in standard form. And my hint to you is these questions, they don't necessarily lead you through step by step what you need to do. Like for standard form, I would probably start by finding the axis of symmetry and the vertex. Then my next step would be the y-intercept. Then I would try to answer the other questions. On the next page, you've got number 15 is in intercept form. So notice those questions, it asks identify the zeros roots. Those are the x-intercepts. That's where you'd start on that question. And then you'd probably find the axis of symmetry and the vertex. And the intercept, you might actually have to plug 0 into x. So for the y-intercept, use x equals 0 to figure out what the y-intercept is. So some people in my other classes were thinking that these blanks were going to lead them through how to do it. Not necessarily. You might have to skip around. And this is how it's going to look on the test. So I wanted to give this to you now to start getting you used to take the form, graph it, then start answering these questions. Number 16 is in vertex form, so you would likely start by finding the axis of symmetry in the vertex, and then start answering the other questions as you can. Okay, number 17. We have not done a problem like number 17 yet. We are going to start doing problems like number 17 next week. So what I want you to think about here is that this equation that they give you is basically that equation. That would be standard form. They're talking about a dolphin's jump. And it says plus 0, so the y-intercept is 0. Basically, this dolphin's jump is going to look something like that. So the dolphin jumps and out of the water at 0, 0, follows this path, and then lands back in the water somewhere over here. They're asking, what is the maximum height the dolphin reaches? So if the x-axis represents the horizontal distance, the y-axis represents the height. So if you can find the vertex, and I know that you know how to find the vertex from standard form, if you find the vertex, you have all the information you need to answer A and B. So I want you to try number 17. Don't shut down because it's a word problem. Give it a try. But if you kind of fail on it, that's okay. Failing is okay as long as we learn from the failure, which we will on Monday. So feel free to fail in a good way on number 17. Okay? On the back, I wanted to do number 19 with you. And after we've done number 19 together, I think you'll be able to do the rest of the problems on your own. We want to rewrite each quadratic function in standard form. So we want our answer to look like ax squared plus bx plus c. We want our answer to have no parentheses in it anymore. So for number 19, I want you to think about, what does squaring something actually mean? Like, what is 4 squared? 16. How did you get 16 from 4? 4 times 4. So squaring something means multiplying it times itself. So x minus 9 squared means x minus 9 times itself. You can't just square both of those things. You have to multiply x minus 9 times itself. Okay, do you remember in Algebra 1 something called FOIL? Oh yeah, first, outer, inner, last. Now personally, I dislike the name FOIL because eventually we are going to start multiplying things where there isn't just a first, outer, inner, last, because there's like 2 things times 3 things and it can get confusing. So I like to call it double distribution because really what FOIL is using the distributive property multiple times. So FOIL, first, outer, that would be x times x and x times negative 9. That would be x squared minus 9x. F and O of FOIL are basically just distributing that x. The I and the L are distributing the negative 9. So negative 9 times x, negative 9 times negative 9. And then don't forget the minus 4 at the end. What do you suppose you do with all these terms? Combine like terms. 81 and negative 4 is 77. And does that now look like standard form? Ta-da! Standard form. So that's what you're doing for 18, 20, and 21. And then the 4 problems at the bottom, I gave you an equation in either standard, intercept, or vertex form, and I gave you the 4 graphs that go with those 4 equations. You just have to pick out the graph. So remember to look for your A value. If it's vertex form, look for the vertex. If it's standard form, you can look for that C value for the y-intercept. So use all of those clues from the equations and pick the correct graph without using a graphing calculator. So try to pick the correct graph just by what you see in the equation.